Lesson 2, solving problems with sets and Venn diagrams. So example 1 is a triangular number is 1, 3, 6, or 10. And they can be represented as a triangular array. So we want to determine the pattern. So really what the pattern is saying is that the triangle, that's the number 1, it's triangular. 1, 2, 3 is triangular. 1, 2, 3, 4, 5, 6 is triangular. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is triangular. So the pattern is this one we started with 1. This one we had it 1 plus 2. This was 1 plus 2 plus 3. This one's 1 plus 2 plus 3 plus 4. So we can guess that the next pattern is 1 plus 2 plus 3 plus 4 plus 5. And we should get 15. And we can draw it 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. And that makes 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the pattern is that each number is the sum of the consecutive numbers starting at 1. So sum of consecutive numbers starting at 1. So we want to write this in set notation. We want to find our triangular numbers from 1 to 100 that are even and odd, and write them in set notation using U, T, E, and O. So I just made a chart. So our first number is 1, and it's an odd number. Then we have 1 plus 2, which is 3, which is an odd number. Then we have 1 plus 2 plus 3, which is 6, which is an even number. Then we have 1 plus 2 plus 3 plus 4, which is 10, even number. So we're going to continue this on until we get past 100, because we want to see the numbers from 1 to 100 that are triangular. So I want you to pause the video and try to fill out the rest of the table. Okay, I started filling out my table. So far I'm at 78. So 78 plus 13 is 91. This is going to be an odd. And 78 plus 13 plus 14 is equal to 105. So this is our last number because 105 is greater than 100. So we want to do our sets. We have U, which is our universal set, so it means everything. So it's all the natural numbers from 1 to 100. All the counting numbers. And the way that we can write this too, no, we can just say 1 to 100, that's enough. Now we're going to do with T. T is all our triangular numbers from 1 to 100, so we're just going to list all our triangular numbers. So 1, 3, 6, 10, 15, 21, 28, 36, 45, 55, 66, 78, and 91. So those are all our triangular numbers. Now we'll do our even numbers. So 6, 10, 28, 36, 66, and 78. And we will do our odd numbers. So 1, 3, 15, 21, 45, 55, 91. So there's all of our sets. Now for part C, we want to determine the number of items in each set. So let's find the number of U. Since it's all numbers from 1 to 100, it is 100. For the number of triangular numbers between 1 and 100 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Our number of even numbers is 1, 2, 3, 4, 5, 6. And our number of odd triangular numbers is 1, 2, 3, 4, 5, 6, 7. Now, another way that we could show this is if we take the number of terms in all of our numbers, all of our triangular numbers, and we subtract the number of even terms, we would be equal to the odd ones. So if we take 13 minus 6, we get 7. So we can manipulate these numbers to solve for each other. And another thing that we should know is that t prime would be the numbers that are not triangular. So that's the complementary set. Any numbers between 1 and 100 that aren't these numbers. And the last part says how many numbers are there that are triangular. So because we can continue on past 100 and we literally could never stop, there's an infinite number. So this is called an infinite set. So if you want to just draw the symbol for infinity for part E, you can. So this is an infinite set. There's no end. Example 2. Record the possible sums that can occur when you roll a 4-sided dice in an outcome table. So 2 4-sided dice, sorry. So if you roll 2 dice, if you get 2 ones, you'd have a sum of 2. If you roll a 1 and a 2, you'd have a sum of 3. You roll a 1 and 3, you have a sum of 4. So we're going to fill the rest of this table out. And if you get 5, I'm just going to put them in red. So 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, and 2 plus 4 is 6. 3 plus 1 is 4, 3 plus 2 is 5, 3 plus 3 is 6, 3 plus 4 is 7. 4 plus 1 is 5, 4 plus 2 is 6, 7 plus 4 plus 3, and 4 plus 4 is 8. So here's our table. And the reason I did them in different colors is because our next thing is we want to find the sets of sums that have a sum greater than 5 and the rows that produce a sum less than 5 in a Venn diagram and in set notation. So first, let's say S is all of our sums. And we know that the number of this is, if we count them all out, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then we have the less than 5. So that's all of my blue numbers. So the number of L is 1, 2, 3, 4, 5, 6. Then we have greater than 5. And the number of G would be all the green numbers, 1, 2, 3, 4, 5, 6. And there's also numbers that are 5. Now, it's not really in the equation, or in the question, but let's find the ones that have a sum of 5. So N of F is 4. There's 4 ways you can make 5. So we're going to put this in a Venn diagram. Now, the reason why I didn't overlap the circles is because there's absolutely no way you could roll 2 dice and have the sum be both greater than 5 and less than 5. You can't do that. It either has to be one or the other. So what this it's mutually exclusive. It means that they're going to be completely disjoint. They won't be anything the same. Let's call this less than, greater than. This is all sums. So outside of those circles, we know we have our 5s. So let's do that in red. They're not going to go in less than or greater than, so let's put them in first. 1 and 4, 2 and 3, 3 and 2, and 4 and 1. And inside our circle, for less than, we have all our blue numbers. So 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, and 3 and 1. So there should be 6 numbers there. There are. And then in our last one, we will have all of our green numbers. So 2 and 4, 3 and 3, 3 and 4, 4 and 2, 4 and 3, and 4 and 4. So there's our Venn diagram of these rules. They are all mutually exclusive. Nothing about them overlaps. There's no subsets. So part C is determine a formula for the number of ways that both sums can occur. So we want to find the way that we can have a sum that's greater than this, or less than 5, or greater than 5. So we want to find the number of L or G, one or the other. So we're going to add both the sums of L and the sum of G. We know the sum of L is 6, and the sum of G is also 6. So really, altogether, there's 12 different ways that you can get less than or greater than 5, which matches this, because we know that there's 4 more ways to make 5, so 12 plus 4 is 16, which is our total sum.